welcome to week 6 of Code Club. In this final week of Code Club, we're going to talk about a feature of Scratch called My Blocks and some more Scratch extensions you could use. Open up another browser window and log on to Scratch so you can follow along. Have fun and let's start coding. The My Blocks feature in Scratch is a special type of block that lets you put other blocks into it so that you can reuse the same code over and over again. This is a little different than looping with the repeat blocks that let you repeat the same code over and over again in a loop. Instead, it lets you set up a custom block that you can use anywhere else in your sprite. The basic concept behind My Blocks, or what are called procedures in other programming languages, is that you give it some input data, it does some processing, and you really don't care how that processing happens, but it gives you some predictable output data. The simple example I'm going to show you is calculating the area of a rectangle. You pass in the length and the width, it does some calculation that we really don't care about how it does it, we just need to know that every time if we give it the same length and width, it's going to give us the proper area for that length and width. To make a new block, you go to the My Blocks category and click Make a Block. The first thing it asks you for is a block name, and this is kind of the verb for what our block is going to do. So for our example, if we're going to have it calculate the area, we can type calculate area. These next two options for add an input number or text and add an input boolean let you add the input data for your block. If you don't have any input data, you don't have to put these in there. But typically when you're creating a custom block, you have some input data. So the number or text allows you to put a number or text into it, and the boolean allows you to put in one of those triangle-sided boolean values so that you can put a test in there. Whatever you type into these two boxes becomes the variable name of this data within your custom block. So for example, if I call this my input number, and I call this my input boolean, then in my custom block, I'm going to have variables called my input number and my input boolean. The label just lets you add some text. So for example, I can just say test text here. And now when I hit OK, it'll just add this to the thing. So it kind of reads like a sentence when you do that. There's another option down here for run without screen refresh. We'll talk about that in a couple of minutes. I'm going to hit OK and it'll create my custom block. So now you can see I have a custom block called calculate area, and it has a spot for a number or text and a spot for a boolean, and then my test text after it that I can't change or do anything with. Anywhere I want to use my custom block, I just have to drag it onto the screen just like any other block. So let's, I'll put a when green flag click, a when spacebar clicked, a when this sprite clicked, and on each one of those, I can put this in here and put the proper variables in place, and it'll run the calculate area custom block in any place where this code exists. How does the custom block know what to do? Well, that is the point of this big pink block at the top that says define my custom block. So it says define calculate area and then my variables. And what I can do is drag any sort of thing in here. So if I want my calculate area to move 10 steps and then also turn 15 degrees and go to a random position, anytime it runs my calculate area custom block, it's going to do those things. If you need to use the variables for your custom block, you drag them right out of here. So if I want to turn my input number of degrees instead of turning 15 degrees, I just drag it into there. If I put a if test in here, I can put my boolean from my input into my if test. I opened up my actual calculate area example. It's example 18 if you wanted to open up and look at it. And in here I have a calculate area custom block that you can pass in two numbers and a get length and width custom block that you can pass in two numbers. And what this example does is I have a rectangle sprite. It keeps resizing that rectangle and telling me what the area of the newly resized rectangle is. You can see in the code over here I call the get length and width and calculate area custom blocks each 2 times, so I don't have to redo the code in each of them 2 times. I just need to call the custom blocks and it'll run all of the code within the custom blocks instead. I'll run the example real quick so you can see how it works. So it's length 198, width 98, and it calculates an area of 19,404. Then it resizes to 99 by 49, and that calculates an area of 4,851. Then it resizes one more time after that, down to 41 by 31, and it calculates an area of 1,271. I'm going to resize the code window so that we can actually look at the definitions of our custom blocks. And you can see I have a defined calculate area length times width, and it calculates the area using those length and width variables using the standard formula, which is length times the width. So you pass in a length and a width number, it multiplies those two together and sets a variable called area, which is our output. The get length and width custom block gets the length and the width of the current size of the rectangle. And it does this using this formula. I'm not going to go through the whole formula, but there's a URL for it on the project page if you really want to see it. Another great Scratch user named Griffpatch came up with this formula. But like I said, we don't necessarily need to know how this works. We just need to know that every time it runs, it gives us the same exact length and width for the same exact size rectangle. One thing that I think is interesting about this custom block is that you pass in the current X and current Y position of your sprite on the screen, and it never actually uses those to do the calculation. But if you notice, it does go to different X and Y positions. So the last thing it does is goes to the X and Y position that you pass in. The output is the length and the width, and it's all calculated without using the input that you passed in. The input is just used to move you back to your previous position on the screen after it moves you around a couple times. I pulled up a different example so that I could show you what the run without screen refresh option means when you create a custom block. By default, Scratch puts a little tiny wait between every block of your code. And sometimes this can be a problem. If you want your code to run really, really fast, having a little wait in there is going to make it run slower. An example of why you might want to use the run without screen refresh option is for pen drawing. A lot of times when you're moving the pen around on the screen, you have to do several different pen drawing commands to get it to happen. And if you have the screen refresh turned on, it runs really, really slow. This example is set up to do pen drawing, and I'm going to run it once with the screen refresh turned off and another time with it turned on so you can see what the difference is. So I'm going to click the space key, and that's going to start my function to do pen drawing. And you can see it's running pretty fast. It's not super duper fast just because of the type of looping I have set up to make it slow when I have screen refresh turned on. But it drew pretty fast, maybe about 10 seconds or so it took to draw that. Now I'm going to edit my custom block and turn off run without screen refresh. Let's run this again and see what happens. I'll hit my space key, and now you can see maybe up here there's a little line that's being drawn across the screen. This is it running this render function. It's putting a little tiny wait between each of these blocks of code, and that's making it take forever to run because we don't have the screen refresh turned off. We've already talked about Scratch extensions a little bit when we were talking about pen drawing and making music, but I wanted to go back and cover a few more topics in that section. If you remember, to add a Scratch extension, you go to the blocks plus sign down here, and that'll pop up a window with a bunch of different options for extensions. The ones we've talked about so far are the music and pen drawing ones. There's also ones to do video sensing, text-to-speech conversions, language translations, and to interact with a bunch of devices that you can hook up to your computer, like a Makeymakey, a microbit, or several different types of Legos. If you remember, to add a new extension, you just click on it in this menu. So I'm going to add the text-to-speech one, and I'm going to add the translate one. And you can see, now I have 2 new block types in my categories over here, and several new blocks listed up in my block listing. The text-to-speech category will make Scratch speak out loud whatever words you type in. So I typed in "Welcome to the world of tomorrow," and if I run this code,
"Welcome to the world of tomorrow,"
it says exactly that. And you have options for what voice you want it. So that was kind of a alto girl's voice. If I change it to tenor,
"Welcome to the world of tomorrow."
It's a man's voice. You know, giant.
"Welcome to the world of tomorrow."
And then kitten.
"Meow, meow, 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 meow."
The other option you have is to change the language, and this doesn't actually make it translate the text. What it does is it makes it talk with a little bit of an accent of that type of language. So if I change it from English to French,
"Welcome to the world of tomorrow,"
it's still saying the same thing, but with an accent. And that gets to be important when we start talking about the translate function. For the translate button, you can see the code block over here. It says translate hello to a different language. And if I just click this here to run it, it translated into Albanian, and I cannot pronounce this word, but that's what hello is in Albanian. I'll change it to something I know a little bit better. And now it says hola, which is Spanish for hello. So this just returns text. It doesn't actually make it speak it out loud. And that would be useful for if you wanted to have Scratchcat, say or think it on screen here. Where the text-to-speech and translate extensions really become powerful is when you combine the two together. So here I'm setting the text-to-speech language to be Spanish Latin American, setting the voice to be tenor, and then I'm having it speak a translation of Welcome to the World of Tomorrow to Spanish. So let's hear that.
Bienvenido al mundo del mañana.
So now it's saying Welcome to the World of Tomorrow in Spanish with a Spanish accent. And you can change the accent. I'll change it back to English.
Bienvenido al mundo del mañana.
And you can hear that it sounds different. So this is where these two things are powerful together, is you can make it say the specific word you want in the language that you want with the accent that you want. And the voice that you want, because I can change it to be a giant and it'll sound it out like that.
Bienvenido al mundo del mañana.
There's one other block in the translate category, and that's a language reporter. And what this reports on is the language of the web browser of the person currently using your project. So I'm using an English language web browser. When I run this code, it reports English. If I was using a Japanese language web browser, when this code ran, it would report Japanese. And where it becomes powerful is in your translate blocks. Instead of having something that you pull from the drop-down, you can pull this language into here, and it will always translate to the web browser language of the person using your project. So if I log in from my English browser and have it translate hello to my language, it'll say hello. But if somebody else is using a Spanish web browser, it'll translate it to hola. The last extension I wanted to show you is the Makeymakey Extension. And this one lets you interact Scratch with a physical device that's hooked up to your computer. The Makeymakey is a device that you hook up to your computer, and it acts like a keyboard. But instead of using keys, you hook these wires up to it. So I have a yellow wire, a white wire, a black wire, and a green wire that I'll hook up to objects. This red wire is what hooks it up to my computer. So the black wire is what they call the ground, and I'm going to connect that to my finger because my body acts as the ground. When I touch any of the other objects, so I have a banana hooked up to the yellow wire, I have a soda can hooked up to the white wire, and I have a staple remover hooked up to the green wire. When I touch any of these objects, it's going to create a circuit into the Makeymakey that pushes a signal to the keyboard that I press the button. And if you look closely, the green wire is hooked up to turn left, the white wire is hooked up to turn right, and the yellow wire is hooked up to the space key. So if I touch what's hooked up to the green wire, the staple remover, that's going to make me go left. If I touch what's hooked up to the white wire, which is the soda can, that's going to make me go right. And if I touch what's hooked up to the space key, which is the banana, that's going to make me jump. If we go back and look at the code real quick, you can see I have when space key pressed, it's a Makeymakey block. When its space key is pressed, it makes Scratchcat jump. When the left arrow is pressed, it makes him point left. When the right arrow is pressed, it makes him point right. So it's a very simple program that uses the Makeymakey to make Scratchcat walk around and jump on the screen. I have the recording set up so that you can see the Scratchcat moving around on the screen at the same time that I do things to the Makeymakey. So first of all, I'm going to make him move left by touching the staple remover. Then I'll make him move right by touching the soda can. Then I'll make him jump by touching the banana. And sometimes you can make him do multiple things at the same time. So now he's moving left and jumping as he goes. Now he's moving right and jumping as he goes that way. Since it's the last week of Code Club, I wanted to show you some examples of programs that really make use of the power of the tools that we've learned within Scratch. I'm not going to go into the details of any of the code on any of these, but I want to show you some of the high points of the main concepts that we learned and I'm using to make these programs work. The first example is a simple ping-pong program that the earth bounces back and forth between the paddles, and you can move the paddles up and down with either W and S or the up and down keys, and whichever person lets it through first is the loser. The first thing you'll notice is that I'm making use of a variable down here called difficulty, and it has the slider that tells how difficult the game is, and the slider for the difficulty sets how fast the earth is going to move back and forth between the two paddles. So it tells me to hit space to start. I'm going to hit space, and then move up and down and see it's going back and forth through. And The right side let it through, so that means the left side is the winner. And that's all this game is. It's pretty simple. Let's go look at the code for it. So you see there's several sprites here for the left player, right player, the earth, a starting message, and a winner message. So, and then there's also some code in the backdrop. And the code in the backdrop initializes a bunch of the global variables. First of all, when the green flag is clicked, and then again, it resets some of them when the space key is clicked. Then when it receives a message, remember we talked about broadcasting and receiving, it sets another variable. In the left and right player, the code is pretty similar. The big difference is in the left player, it's listening for the W and S keys to be pressed. In the right keys, it's listening for the up arrow and the down arrow to be pressed. The earth is where the actual movement happens, and this is how it knows to bounce off of the left or the right player. And you can see down here, when it moves, this is where we use that difficulty variable. It moves based on how many steps, based on how difficult it should be. And it can tell based on the X position whether the left player or the right player is the winner. And then down here, it says if it's touching the left player or it's touching the right player, so it's using the sensing operators to determine what other sprites it's touching, then it knows to move in the opposite direction. This is what makes it bounce between the two paddles. One other important thing I wanted to note is that in most of my sprites and in the backdrop, I have a when green flag clicked. And what this does for all of my sprites is it resets things back to normal. That way, every time I don't have to drag things back into where I want them to be. So, you know, on the left and the right player, let me scroll back up here, it resets it to a costume, points it in the right direction, and makes it go to a specific place. On the earth, it makes sure that the earth is showing and puts it in the right position on the screen. For the starting message, it just makes sure that the starting message is showing. For the ending message, it makes sure the ending message is not showing. So, like I said, this is a very important thing when you have, you know, more advanced programs you want to make, to have, when the green flag is clicked, you have everything reset back to a normal thing, so you don't have to drag things around or reset variables by hand. The next example is a real simple snake chasing game that uses pen drawing. So you go around, your snake grows as you pick up apples, and then if you hit yourself or you hit the side, that makes your game over, and then it gives you a score right at the end. We can switch back into the code, and you can see that for this one I only have 3 sprites, a head, a tail, and an apple. And then in my backdrop, I have very little just kind of setup code and then the game over code. And, you know, I'm using broadcasting and receiving to show that when the game is over. You'll notice that there's 2 lists here called X list and Y list. And those store the current list of all the X and Y positions that the snake occupies on the screen. And that's how we're able to tell whether the snake crashes into itself. Because the tail is just a pen drawing. There's no way to tell just if the 2 sprites are touching, because the tail sprite basically has nothing in it. So we need something to test whether the head is touching the tail. And what we test is whether the current position of the head matches anything in the XY list. And if it does, that means that the snake has crashed into itself and the game is over. The tail sprite is where it actually draws that green snake out on the screen. And it does this by looping through, and every time it erases the entire snake and redraws it using this draw custom block. And in the draw custom block, we loop through that XY list, put the pen down, and draw each individual XY coordinate on the screen with the pen drawing. One thing you might notice is that we only use the draw custom block once in our script. And that would kind of lead you to think that we don't actually have to have this custom block. We could just drag this code up into where it says draw here, and it would run it every time. But if you look at the definition for our draw custom block, it says run without screen refresh. And if you remember from when we talked about pen drawing and custom blocks, that makes this custom block run really, really fast. And we need that to happen. Otherwise, the snake would move too slow. So this has to be in a custom block so that we can have it run without screen refresh and run really fast. This last example I want to show you is a simple breakout game. And I'll play it real quick just so you can see what's going on. And this one I wanted to show you because it's a good example of using clones. Every one of these blocks in the breakout session is a clone of one sprite instead of having lots of different sprites. We can switch back to the code and look at the block sprite. And this has the important clone related code to it where when the space key is pressed, it loops through a certain number of times and creates a bunch of clones. So you can see there's create clone of myself inside these loops. So it loops through a bunch of times and creates clones. Then I also have a when I start as a clone, and this sets up a bunch of variables that keep track of the clones. You see I have a list of clone X positions and clone Y positions, clone numbers, the clone's block row and block column, so where it is on the screen up here, and then it shows the clone. One other interesting thing about this code is that the way I calculate how a ball bounces off of a block requires there to actually be a sprite in place. And since these are all clones and not sprites, I can't calculate based off of this. So instead I have this black block, and it uses that to calculate the angle that the ball should bounce off of a block. The way this happens is when the program detects that the ball is going to be bouncing off of a clone, it moves this black block behind the clone, and the ball actually bounces off of this instead of bouncing off of this. And you never see this because it's kind of hidden behind the clone. I'll switch to the ball code, and you can see it says, when I receive bounce off of a block, one of the first things it does is broadcast move to clone block position. And what that does over here is it says, when I receive move to clone block position, it moves to the proper position of where it's supposed to bounce off of. And then back in the ball, it says bounce off of the sprite, block bounce target with an angle. So that's saying the ball is going to bounce off of this, but this just moved because of this broadcast receive. It just moved behind the current clone that it's supposed to bounce off of. I'm not going to go into any more details of any of this code. I just wanted to show you, I zoomed out way far on the heads code, and you can see there's just a ton of code that makes up the head, and the apple also has a lot of code. I had to zoom out in order to fit it all on the screen. And this is just to show you, like, to get a powerful game going, you need a lot of code that interacts with each other to do it. And this is where stuff like broadcasting and receiving and clones and stuff like that come into play. And then using variables and lists to match the data up between your various sprites and the stage so that everything matches and works how it's supposed to. It's just a lot of code, a lot of variables, stuff like that you need in order to coordinate a big program. This last example is a good example of art that can be done with Scratch versus a game, which is what I'm used to doing. And this somebody else made. My daughter found it and thought it was cool, so I thought I would show it to you guys. So if I click play, it plays the person's logo. And then it starts this cool animation with some music. If I move the mouse around, you can see it's got these stars that follow it. So this is a good example of interactive art that you can do with Scratch. I'll switch to the code that runs this, and there's a couple things here that I wanted to show you that I don't do in any of my programs, but you guys, you can look in here and see examples of things that I haven't done before. And you see there's tons of sprites on here. I'm going to go to this costume 1 sprite that makes use of both of the things I want to show you. And the first one is that it uses this mathematical operator cos, which stands for the cosine. So it's taking the cosine of this fly number and using that to make the butterfly fly. I don't know. I'd have to look more closely to tell for sure what it does, but it's using an operator that I don't have in any of my code that I've shown you as an example. And it's this mathematical, advanced operators like, absolute value, floor, ceiling, square root, sine, cosine, tangent. All of these operators are things that I've talked about, but I've never used in my programs that I show you. The other thing is that there's a lot of things in here. If you notice, when the green flag is clicked, it resets the timer. And back in here, there are things where when the timer reaches a certain level, it makes something happen. So they're using the timer in this program to make things happen. So I thought that was another cool example of something where I talked about the timer, but we never really showed an example of what it can do. The code in this example, though, is almost secondary to the beautiful costumes and backdrops that they created. So, you look in the backdrops here, and you see this beautiful patterns that they have in this one. If we go to some of these other, like the head backdrop, or the head sprite, you can see this head drawing that it was drawn all in Scratch using vector mode. And there's a bunch of different costumes. This person spent a ton of time doing drawing. And this is something, if you're into art, you can do all of this in Scratch. These examples just touch the surface of the power of Scratch. You can build almost anything that your imagination can come up with. If you have questions on how any of these work, shoot me a comment on YouTube or on Scratch, and I'm more than willing to help. That's it for week 6 of Code Club and this set of videos. I hope you enjoyed them. Now go out and do some coding on your own. Have fun and be creative.